So power supplies do much more than you think they do, and that includes converting AC to DC. Beyond converting AC to DC, they also have to smooth out voltages and stuff like that. And beyond smoothing out voltages, they have to control voltage and voltage versus current for different parts of the device. Some things operate higher voltages, some operate higher currents. Briefly, all that means is in an AC alternating current, I'll just go back to here. Part of it goes up and down, where it's plus or minus, plus or minus. Another one goes up and down, plus or minus, plus or minus. In the opposite, if it's two-phase. In DC, it's just one line is always positive and one line is always negative. In some other versions, you might have three waves going up and down, that they all cancel out to zero. In all these methods, if you add the plus and minus parts, they all cancel out all the waves together to make either positive or negative. If you have two waves, one opposite of another one, which I put red and blue here, together, the green is the power, and you can see that the power goes up and down, up and down. There's a part where both of them are zero. In three-phase, it's more efficient. It's always a constant power you get into your device. But in a two-phase, you definitely need to smooth it out. And most things are two phases because it's simpler to produce. It's more efficient to produce usually, and it's usually, like in other ways, simpler to design, like the electrical wires for it, even though it's not as smooth. Three-phase, not as common, but a lot smoother. And that's where your high-powered electronics come in, like your like some dishwashers and stuff. However, even with this one, you couldn't get bumps. But when you convert this into DC, you can see there's going to be bumps because it fluctuates. Even this three-phase is going to be bumps, because what happens with the bumps is that it's not always converting the same efficiency throughout this whole entire cycle. These bumps are then smoothed out, so your electronics cannot run very smoothly with bumps by using capacitors. And capacitors work by smoothing out it in a variety of ways, but one way is very simple. They store up some of this electricity over here, that's when it's producing most, and then bring it back down to here when it has the least, smoothing out the fluctuation. Now, when you smooth out the fluctuation, up to 20% of electricity can be lost. And then you can have it multiple times. This is pretty darn bad, it sounds like. So I have come up with a couple ways of making the device more efficient. And one way is some of your stuff in a computer actually does not need to run on this nice voltage, because your fan can handle very easily fluctuating voltages at this level, and it doesn't really affect efficiency. Not only your fan, to less extent your battery can handle fluctuating voltages like this, and other electronics are more or less sensitive. So one thing is to have a kind of a top power skimmer. And what this top power skimmer would do is we would take some of this energy from the two-phase and we would just have some of this go to a capacitor and charge it. Now the capacitor is what normally smooths out the voltage, but some of the power we don't divert to a capacitor, is put for normal. And this one will have still the fluctuations within it. Now, a capacitor will give the steady stream voltage that you need for the more complex electronics, and you might lose some power. The bigger thing here gives the non-steady stream voltage that you can use for other electronics that you lose less energy to make. And then you can have in between, like you have some power by 20% this and 80% this. Another thing to make this whole system much more efficient is that you could theoretically put another switch over, well, you could put another switch that also just gives power when it's skimming from when it's extra power here produced, it skims from the top. Because some of this stuff is lower power, so you don't want the high power. Instead, you skim from that top extra power that this whole thing is running at, and you use that to power the fan. To already smooth out the function a little bit, the function will look like this. And then you would have to store less power, only power over here and here to store it over this block, instead of storing it over this entire block. A third way that this thing can increase it is this capacitor can act like a battery. Capacitor is one, and the bigger it is, it could actually act like a sizable battery for a few more charges. And the bigger a capacitor is, the more efficient it is. And the longer it can store electricity, and the smoother the function it produces. Because a capacitor discharge looks like this. But a small capacitor discharge is very quick. It's whoop, like that. A bigger capacitor doesn't like that more, and it's smoother, so it smooths out stuff better. And it can hold charge longer, more efficient, and better smoothing. Another way this whole device could be made to be more efficient is, instead of having, and also if the capacitor acts instead of a battery, acts to smooth out and as instead of a battery, it actually is better, because then you can get rid of some of the battery storage and converting stuff to battery electricity, which saves a step. So instead of going from here to then using this to a battery, then out, you're just going here and storing electricity here, so you don't have that step where you store it twice and lose power in the middle, or from here to here, where you lose power during the battery phase. Another thing we could do to save power actually would be to have solar cells run the electronics that need more steady state voltage, because they produce more steady state themselves. Well, thank you for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. And also, if any of you for future videos, comments, or suggestions, please leave them in the comment section below. Thank you very much again. Goodbye.